In this lesson, we are going to learn how to solve and graph one-variable inequalities. Inequalities are statements that compare two expressions. The expressions can be separated with a greater than symbol, a greater than or equal to symbol, a less than or equal to, or a less than symbol. Your target today is, I can solve and graph a single variable inequality. To do that, first we will review graphing single variable inequalities. Single variable inequalities. One thing to remember, always read the inequality starting with the variable. Also, if you have a less than or a greater than sign, you will use an open circle in your graph. And if you have a less than or equal to or a greater than or equal to symbol, you will use a closed circle in the graph. Let's look at 3 examples to illustrate these rules. Sorry about the numbering, it's a little off, but we'll just refer to them as the example numbers that they are given. So example number 1 says x is greater than 4. So first make sure you read in respect to the variable. So x is here, the symbol is greater than, the number is 4. So we're going to find 4 on the number line, and then we're going to place an open circle because our symbol is just greater than on the 4. So we place an open circle on the 4. Then we decide if we're going to shade left or right. Since the symbol is greater than, we're going to shade all the numbers greater than 4, so that means we are going to shade to the right. We have just created a picture of the solutions for x is greater than 4. To check to see if your solution is right, all you have to do is pick a number that you shaded, for example, the number 8, and plug it into the inequality. Is 8 greater than 4? Yes. So your picture is correct. All right, let's look at number 4. Now you notice in number 4 that the variable is not first, but we're still going to read the example like the variable was first. So we have m is less than or equal to -3. So I'm going to find -3 on the number line. I'm going to put a closed circle because it has the greater 2 sign on -3. So there's my closed circle on -3. Now, I'm going to look and it says m is less than, so I'm going to shade all the numbers that are less than -3. So that means I'm going to shade to the left. And now I've just created a picture of the inequality m is less than or equal to -3. To check my solution, I can pick any number in the shaded area, -6, and fill in -6 for n. So is -3 greater than or equal to -6? Or you could read it like we have been, -6 less than or equal to -3? Yes, it is. So we are correct. The last example that I have here is instead of giving you the inequality and drawing the graph, you're now going to have to write the inequality that represents the graph. So the first thing you're going to do is start with a variable, and I'm going to use x. Then I'm going to decide what kind of symbol I'm going to use. Since I have a closed circle, I know it's going to have an equal to part, and since it's shaded to the right, to the greater than direction, my sign is going to be greater than or equal to. So x is greater than or equal to, and then the number that my circle is on represents my number in the inequality, so that number will be 4. So my inequality for this graph is x is greater than or equal to 4. So that takes us halfway to our target. We have learned how to graph a single variable inequality. So now let's look how to solve and then graph our solution to a single variable inequality. We're going to use our rules for solving equations to solve for the variable and the inequality. but we are going to add one more rule. The rule is if you multiply or divide by a negative number to solve the equation, you have to flip the inequality. And the main thing you have to remember is that in the solving process, if you multiply the equation or divide the equation by a negative number, that is when you flip the inequality sign. So let's look at some examples. I have 4 examples here. The first one, example number 1, is -5 is greater than or equal to x minus 9. So I'm going to solve this inequality for x. So to get x all by itself, I have to add 9 to both sides. Because the opposite of subtracting 9 is adding 9. So the 9's cancel out, and I get x is less than or equal to -5 plus 9 is a 4. So my inequality solution is x is less than or equal to -4. So now I'm going to graph that. At -4, I'm going to put at +4, I'm going to put a closed circle because I have the equal to sign. So closed circle on +4. And then we're going to read, starting with the variable, x is less than or equal to 4. So I'm going to shade the numbers that are less than or equal to 4. And there's a picture of my solution. So now to check it, I can put one of these numbers in the shaded region back into my original inequality to see if it is true. So we're going to pick -3. So if I have -5 is greater than or equal to, instead of x, we're going to put in -3 minus 9. Well, we're going to simplify -3 minus 9, and we have -5 is greater than or equal to -12. Since that is a true statement, remember, the bigger the negative number, the smaller it is, then we know that our solution is correct. Moving on to example 2, number 5. This one reads, -13v is greater than or equal to -208. So to solve this one, we have to get rid of a multiplied by -13, so we are going to divide by -13. So when you divide by -13, the -13 divided by -13 cancels out, and you're left with v, and then this is our new rule. Since we divided by a negative sign, we have to flip the inequality. So instead of it being greater than or equal to, now it's going to be less than or equal to. And then now all we have to do is take -208 divided by 13. Since I don't have a calculator handy, I'm going to come over to the side and do this one by hand. So I have -208 on the inside, -13 on the outside. I know 2 negatives are going to make a positive, so I know my answer is going to be positive. 13 goes into 20 one time, so we're left with 20 minus 13. 20 minus 13 is 7. Bring down the 8. So 13 divided by 78 gives me 6. 6 times 13 is 78. So -208 divided by -13 is a positive 16. So now I have my answer. V is less than or equal to 16. So I go to 16 on the number line, which I only have up to 10, so I'll have to extend it. Here's 16. All right, and then I will put a closed circle on 16 and shade to the left. Close circle on 16 and shade my number line to the left. So my picture of my solution, that V is less than or equal to 16. third example says that 7 times 2x minus 4 is less than or equal to 70. So the first thing I'm going to do is distribute the 7 to everything inside the parentheses for my first step for solving for x. So 7 times 2 is 14x, and 7 times negative 4 is a negative 28, is less than or equal to negative 70. All right, my next step is to add 28 to both sides because I want to get the x term all by itself. So I'm left with 14x is less than or equal to -42. -42. And then I'm going to divide by 14 on both sides. And I'm going to get x is less than or equal to 3. So x is less than or equal to 3 is our solution. So to graph that, we go to 3. And since it's an equal to inequality, we're going to put a closed circle on 3. And then since it's less than, we're going to shade to the left all of the numbers that are less than 3. All right, our final example is an equation that has multi-steps and variables on both sides. So the first thing I'm going to do to simplify this equation is I'm going to look to collect any like terms. Here I have a number and an x term, so they're not going to go together. Here I have an x term, a number, and a number, so I can collect the 4 plus 1. Well, 4 plus 1 is 5, so I can have negative 10 minus 2x is greater than x plus 5. Now I want to get all the x terms on one side and all the number terms on the other. So I'm going to choose to move the x's over to the right side by adding 2x to each side. So this gets rid of the x terms on the left and puts them on the right. And then since I decided to put my x's on this side, I want to get rid of my numbers on the left side. So I'm going to subtract 5 from each side. So those cancel out. So now I'm going to collect my like terms on each side, and I have negative 10 minus 5, which is negative 15, is greater than x plus 2x, so that's 1x plus 2x, which is 3x. Then I'm going to divide by 3 on each side. So I got x is less than negative 15 divided by 3, which is negative 5. So I'm going to put an open circle on negative 5 because I don't have an equal to sign. And then since it's reading x is less than negative 5, I'm going to shade to the left. So there are your 4 examples for solving and graphing single variable inequalities. So tomorrow when you come into class, we'll practice these and answer any questions. I expect you to have all of the examples completed. Remember, you can pause this video, you can rewind it, you can watch it again if things are confusing. Come in with any questions you have, and I will be happy to answer them. Hopefully this all works out.